While discussing the first law, we found that it was necessary to consider all the forces act on an object, the net force, to determine its motion, specifically a pushing or pulling force and the unseen frictional force. Newton added another idea to this. What if the same net force was applied to different objects with different masses? How would the motion of those objects compare? This one's a little easier. Our experience shows us that if you push a heavy object, then push a light object, the light object will move quicker. Its acceleration will be greater. Our experience also tells us that if we push an object with a large force, its acceleration will be greater than if we push it with a small force. So now we have concepts of considering all the forces on an object and taking into account the mass of the object. This leads to Newton's second law. So the acceleration is proportional to the force, and the acceleration is inversely proportional to the mass. Newton's second law states that the sum of the external forces on an object is directly proportional to the product of its mass and acceleration. Note that the force and acceleration are vectors. That is written sigma F equals ma. Another way to write it is A is equal to sigma F over m. This way clearly shows that the acceleration is determined by both the force and the mass. Now for such a simple equation, it hides a trap. Any ideas? Think of what this equation tells you about the motion of the object, and think about what it doesn't tell you. The trap is that the net force does not tell you how the object is moving. That is, it does not give you any information about its velocity or displacement. It only tells you the object's acceleration, its change in velocity. So an object may be moving at 300 meters per second with zero external force on it, so it has zero acceleration, which means it keeps a constant velocity of 300 meters per second. Or an object could be stopped and still not have any acceleration, not have any external force.